limits at infinity. In this lesson, we are going to find the limits at infinity of polynomial functions, rational functions, and the functions involving square root. So that means we're going to find the limit as x approaches infinity of some function f of x, or we're going to find the limit as x approaches negative infinity of f of x. First of all, we need some rules to establish. We are going to establish those rules, basic rules, using our knowledge about the basic graphs. Here is the graph of 1 over x, and this is the graph of 1 over x squared. So all the graph with n is odd, like x to the n where n is odd, going to look like this. All the graphs with 1 over x to the n where n is even, 2, 4, like that, going to look like that. So n, either way, what we see here as limit x goes to infinity, 1 over x to the n approaches 0. As x approaches infinity, both of these going to approaches 0. And also, as x approaches negative infinity, it doesn't matter whether power is even or odd, as x approaches negative infinity, it is going to approaches 0. So we are going to use these rules when you want to solve problems. And also, we're going to use our knowledge about the basic power functions. This is the graph of x squared, and this is the graph of x to the third. So all the graph of the even power, x to the n is even, going to be looks like this, x squared. And all the graph with x to the n where n is odd, going to looks like this. So that means as x approaches infinity, x to the n approaches infinity, and as limit x approaches negative infinity, x to the n approaches infinity if n is even, or negative infinity if n is odd. It approaches infinity if n is even. So we're going to use these basic rules when you want to find the limits of the polynomial functions and rational functions and the functions involving square root. Now let's look at this example. So here we want to find limit as x approaches infinity of f of x. Now this is a polynomial function. What we know is that the end behavior of a polynomial function is given by that of a leading term of the polynomial. So therefore the limit x goes to infinity of f of x is same as limit x goes to infinity of negative 7x to the fifth. Now we know x to the fifth graph looks like this. So as x approaches infinity, it goes to infinity. Now what we have is negative 7x to the fifth. So that is a graph going to be like this. So that means as x approaches infinity, this will approaches negative infinity. And clearly, as limit of x approaches negative infinity, f of x is same as limit x approaches negative infinity of negative 7x to the fifth, and which clearly approaches the positive infinity. So right here. Now let's look at the example number 2. So here we want to find limit x approaches infinity of f of x. Now this is a rational function. The end behavior is given by 8x to the fifth over 2x to the fifth, and then x to the fifth cancel out. So n behavior, this is going to have the horizontal asymptote at 4. So you can see this graph is going to, if you look at the n behavior, is given by 8x to the fifth over 2x to the fifth, which is 8 over 2 or 4. So this graph is going to have a horizontal asymptote at 4. Mean as x approaches infinity, this is going to go to 4. Now let's see how you use the algebra to do that. Now this is same as, so the strategy is to use divide both numerator and denominator by the highest x to the power of the denominator. So that will give us 8x to the fifth over x to the fifth minus 5x to the fifth over x to the fifth plus 1 over x to the fifth, that is numerator. Denominator will have 2x to the fifth over x to the fifth minus x to the third over x to the fifth. Now if you simplify, this will cancel out, you get 8 minus, this will cancel, this is x to the 2, right? This will cancel, x to the 2 cancel out, you get a 5 over x to the third, and then you get a 1 over x to the fifth. And over here, this cancel out, you get 2 minus, you get a 1 over x to the second. Now as x approaches infinity, all these terms going to go to 0. This term goes to 0, and this goes to 0, and this goes to 0. So what is left is 8 over 2, or which is equal to 4. So whenever we have a rational function, we need to find the limit at infinity. The strategy is to divide both numerator and denominator by highest x to the power in the denominator, and then basically simply use at the end, then use this rule, limit x goes to infinity 1 over x to the n, it approaches 0. Example number 3, and we want to find limit as x approaches infinity of this function f of x. Now this is a rational function. The denominator polynomial, the degree is 1. So we are going to divide both numerator and denominator by x, highest x to the power in the denominator. So this will give us limit x goes to infinity, x squared over x plus x over x over 3 over x minus x over x. So which is equal to x squared over x, which is x, and this will give you 1, and this is 3 over x, and this is minus 1. So what we see here is that as x approaches infinity, this part goes to a 0, and this goes to infinity, and so the numerator part goes to infinity. So you get infinity over negative 1, or that means this will approach as negative infinity. But if you notice here, the n behavior of this rational function. So the n behavior is given by the leading term of the numerator, which is x squared. The leading term of the denominator, which is negative x. So the n behavior is given by negative x. So clearly as x approaches infinity, this will approach as negative infinity. So we want to find the limit as x approaches infinity of this function. Now what you see here, now if x approaches this one infinity, this will approaches infinity, and this also approaches infinity. So we get to have an infinity minus infinity situation. So we need to figure, it's called undetermined. So we need to figure it out what that can be. It can be 0 or even infinity. Now the strategy is here. This looks like a minus b, so we are going to use the rationalize the numerator strategy here. We are going to use x squared plus 1 plus x. We divide and then multiply by the same thing. So you get a parenthesis. Now the numerator is have the a squared minus b squared situations. So we know a squared minus b squared is equal to because it's a minus b times a plus b will give a squared minus b squared. So a squared means squared of this. So that means we get limit as x approaches infinity of x squared plus 1 and minus b squared. B is this one, minus x squared over square root x squared plus 1 plus x. So now x squared cancel out. So we have limit as x approaches infinity of 1 in the numerator. And the denominator we have x squared plus 1 plus x. Now you can easily figure it out, this one, because as x approaches infinity, this will approaches infinity, and this also approaches infinity. So the denominator approaches infinity, so result has to be 0. But if we need to show the work, we do same strategy as we did earlier. We are going to divide both numerator and the denominator by highest x to the power in the denominator. Now what is the highest x to the power in the denominator? This x squared is within a square root. In effect, it has a square root of x squared, which is x. So basically, highest x to the power is x in the denominator. So we are going to divide everything by that one. So you get 1 over x in the numerator. And the denominator you get x squared plus 1 divided by x. And this one x divided by x. So here we get limit x goes to infinity 1 over x. So what do you think over here? When x take inside the square root, it becomes x squared. So which is same as x squared over x squared plus 1 over x squared. And then you have plus x over x, which is equal to 1. Again, we can still simplify. X goes to infinity, you get a 1 over x. And here we get 1 plus 1 over x squared and plus 1. Now as x approaches infinity, 1 over x, this will approach 0. And this also approaches 0. So what we get is the 0 over square root of 1 plus 1, which is square root of 1 is 1. So 1 plus 1 is 2, or 0 over 2, so which is equal to 0. So now it's not difficult to guess the limit over here, because the end behavior of this function going to be that of square root of x squared, which is actually x. So the x minus x equal to 0. Or as x approaches infinity, this approaches infinity and this approaches infinity is the same speed. So that's what infinity minus infinity becomes 0 in this situation. However, if you had instead of x squared, say if you had x to the 4th here, in effect that will be square root of x to the 4th or x squared. So as x approaches infinity, this approaches infinity. X approaches infinity. So it looks like infinity minus infinity. However, that will not approach 0, because this will approaches infinity faster than the x approaches infinity. So therefore, the overall, it will approach infinity.